Now we are going to solve the problem number 4.10, which is given in page number 214 in chapter 4. Here what is mentioned here, first we have to understand the problem. Here one solenoid, a lengthy coil that is wound on a soft iron core, and the relative permeability of the soft iron core is 800, and the radius of each turn of the coil is given r is equal to 3 centimeter, and the length of the solenoid is 40 centimeter, and the number of turns wound on the solenoid is 500 turns. You are asked to find out the average EMF which is induced in the coil when the current changes from 0 to 3 ampere in the duration of 0.4 seconds. First you should know the basic formula. So first you should know what are the formulae which are required to solve the problem. First you should know the formula for L, self-inductance of the coil. L is equal to mu n square A L is a formula to calculate the self-inductance. Here relative permeability is given, therefore instead of permeability, relative permeability is given. So mu can be replaced by mu naught mu r n square, and radius of the coil is given, therefore A can be replaced by, since the area of cross section of the coil is circle in nature, A can be replaced by pi r square into L. This is the formula. So by using this expression we can calculate, but they didn't give the value of n. Instead of that, capital N is given, length is given. We know very well that small n is nothing but n by L. Are you clear? Number of turns per unit length can be measured by n by L. So instead of n, we can substitute n by L. So in the next step we can write mu naught mu r. Instead of n, I am substituting n square divided by L square can be written, and then pi r square L can be written. Here one L can be cancelled. So what is the rest of the formulae? The rest of the formulae is mu naught. So here the deriving the formula is very important. Without deriving the formula you can't do the problem. That's why first I am teaching you how to derive the formula. Mu naught mu r n square pi r square whole divided by L is the formula. So formula is ready to calculate the self-inductance. So what is the next step? By using this formula, we are going to calculate the self-inductance. Now, in the next step, we can write the formula. So the required formula is mu naught mu r n square pi r square whole divided by L can be written. Though it is given in the textbook, already it is solved, you should know exactly how to solve the things by deriving the formula. That's why I am working out the problem. We know the value of mu naught, 4 pi into 10 to the power of minus 7 Henry per meter. Mu r value is how much? 800. And then n, number of turns wound on the solenoid is 500, power of square into r square. It is given in terms of centimeter. So 3 centimeter must be converted into meter. 3 into 10 to the power of minus 2 power of square. So it is substituted, divided by length of the solenoid is 40 centimeter. So 40 centimeter can be written as 40 into 10 to the power of minus 2. So everything is substituted. Okay. So with the help of log book, you can solve. Clear. You have to use a log book to solve the problem. Certain things can be simplified. Okay. 4 into 5 into 10 to the power of minus 7 into 800 into 500, 25. Okay. So 25 into 10 to the power of 4, it can be written like this, into 9 into 10 to the power of minus 4 whole divided by how much? 40 into 10 to the power of minus 2. So later you try to simplify with the help of calculator or with the help of logbook. The answer would be, the L value would be 1.77 Henry. What is 1.77 Henry? That is the self-inductance of the given solenoid, okay, with the core. Understood? So finding the value of L is very important. Only then we are able to calculate the average EMF which is induced in the coil. So let's go to the next step, okay. Here we are going to find out the average induced EMF which is induced in the solenoid. What is the formula? Xi is equal to minus L di by dt. Since it is a self-induction, we have to use the formula to calculate the average EMF which is induced in the coil. Xi is the induced EMF. L value is already found out, 1.77 Henry into change in current. Here the current changes from 0 ampere to 3 ampere. Therefore, 3 minus 0 can be written. That change occurs in the duration of 0.4 seconds. So after calculation, the EMF value would be minus 13.275. Okay, and then the EMF must be measured in terms of volt. Here that negative sign that indicates the consequence of Lenz's law. Are you clear? The EMF that opposes the change in current. The EMF, that one opposing the change in current in the coil. Okay, the rate of change of current is a cause for the production of EMF. But EMF itself opposing the rate of change of the current. That's why to represent the meaning of the Lenz's law, here that negative sign is indicated. So therefore, this is the opposing EMF which is induced in the coil. Very simple problem may be asked in 5 mark or in 2 mark. Okay, thank you.